Good afternoon, everyone. I think very few people have joined us today. We'll start with the class now. In today's class, we are going to learn about two main topics. And the first topic is going to be probabilistic models. Okay. So last class, we were learning about different models, if you all remember. So initially, we started off learning about supervised models, right? So we learned about a classifier and regressor. And in yesterday's class, we learned about linear models, tree models, hierarchical models, distance-based models, etc. So today we are continuing and looking at another type of or another class of machine learning models that are going to be able to um, uh, determine the functionality, like be it a classification task or a regression task. It's going to be done based on probabilistic methods. Okay, so this is entirely um, purely statistical based methods. Okay, so statistical concepts are going to be used here. So, quick refresher of things that we know already, right? So, we all know about the normal distribution, right? So, um, normal distribution is any distribution that follows a Gaussian distribution, which is essentially you all would have studied about the bell curve in school. Yes. So uh, generally, most of the data that we work with falls under the normal distribution. Yes, very rare or occasional cases or very specific cases do not form or do not fall under the Gaussian or the normal distribution, but otherwise it will typically fall under this category, right? So normal distribution could be um, a series of data, such as the height of people in a class or the height of people in a particular school, right? So there you have a distribution, and if you take the mean, it's going to be mostly it'll be between a particular range, and the average would always be a central value, right? So distribution of errors in any measurements, distribution of the blood pressure measured for different patients, right? So if I take these set of values, all of these fall under normal distribution, right? So that is why I told most of the data that we work with will typically fall under this normal distribution, right? So when do you say that a data is normally distributed? Okay, when it satisfies the criteria that the mean, median, and mode are the same values. Okay, so what do you mean by mean, median, mode? What is mean, median, mode? We would have learned it already. Mean another. Mean is the arithmetic mean. We would have learned about all this. Mean is nothing but the average. Okay, so mean is average. Median is central value or the middle value in a range. Okay, so you have some high values, you have some low values. For example, if I take a class of 50 students and the height of the students varies between, let's say, 140 to 150 centimeters, right? So between this 140 to 150, whatever is the central value, that is 145, will be the median. Mode is the average of all the students' heights. Mode is nothing but the most frequent value or the most repetitive value in the distribution. So, for example, in the class of 50 students, yeah, someone has given the answer. Good. Mode is repetition. So let's say I told 140 to 150 is the range of all the students' height. So let's say many students fall under the category or they have their height as let's say 145, 146, that range, right? So when you take this 140 to 150 normal distribution, the mean value, which is the average of all the 50 students' height, let's say it comes under or comes approximately to 145. And median, the central value is again 145. And the mode, that is the most repeated value, that is many people in the class are uh, around 145, 146 centimeters, which is approximately, let us take it as 145. So when mean, median, and mode are the same, it means that your distribution is following a normal distribution, right? So the area under the bell curve is told that the entire area is equal to 1, right? And normally distributed curve is symmetric at the center along the mean. Um, so, think, okay, I don't have a picture of normal distribution, but anyhow, maybe I'll do one picture. So this is how your normal distribution bell curve would look like, right? So you have different values and yeah. So typically this is how you draw your bell curve, and the area under the curve, that is the entire shaded blue region, is totally equal to 1. And the central is the mean, mode, and median value. And on this side you have positive values, on this side you have negative values, right? So this is typically how your normal distribution would look like. Okay. So going back to the presentation. So most of the probabilistic methods make use of the normal distribution or assume that your data is normally distributed, and only in that case you will be able to apply these. Okay. Not all data, as I told, is going to be normally distributed. So if your data is not following normal distribution, maybe it has uniform distribution or some other distribution, then you need to find out some other model and use it. If you're going to use these approaches for data that is not normally distributed, then your model result is not going to be accurate. Okay. So the first algorithm or the first model that we're going to learn under the probabilistic method is the naive Bayes. So this is one of the most commonly used, very basic model that makes use of the Bayes theorem, right? So Bayesian theorem, again, a concept most of us would have come across in schools, right? So here, what the Bayesian theorem does, or what it is used for, is to predict the probability of occurrence of some event based on another event, uh, another related event, right? For example, if I'm tossing a coin, if I want to find the probability of me getting heads, then I'll apply the Bayes formula, right? And what is the probability of getting tails? What is the probability of you know um, both head and tails, etc. And I'll be calculating based on that formula, right? So here you calculate the posterior probability of each class, and the class with the highest probability is chosen, right? So in a random coin toss, what is the probability of getting a head? What is the probability of getting a tails, right? So if whichever is getting higher value, that is a resultant class that you're going to get. Okay, so this is with respect to a classification problem that they've mentioned this. So few steps that are going to be involved when you're working with a naive-Bayes model. As usual, you first collect your data, right? So your data has some features and a target. The target has labeled classes like class A, class B, yes, no, bird, cat, so some class like that. And for each feature in the data set, calculate the conditional probability of the feature given the class. Okay, so this again, we make use of statistical formulas here, right? So how do you calculate the probability for each of the feature? Okay, so this is done by counting the number of times the feature occurs in the samples and dividing by the total number of samples in the class. So let's say I take data of 100 random coin tosses, and out of the 100 random toss, 70 times I got heads, 30 times I got tails, right? So then if I need to calculate the conditional probability of heads and conditional probability of tails, for heads it is total number of times heads occurred, which is 70, divided by total number of answers, which is 100. So 70 by 100. Whereas the same thing for tails is going to be 30 by 100. Okay. So once you're done finding the conditional probability of each feature, you calculate the prior probability of each class. Okay. So this is done by counting number of samples in each class and dividing by total number of samples in the data set. Okay. So um, like how many in my entire data set, how many heads are there, how many tails are there, right? So based on that, I find the prior probability, and given a new sample with a particular set of features, calculate the posterior probability of each class using Bayes theorem, and conditional probabilities and prior probabilities are calculated in steps 2 and 3. Okay, so based on this, when a new data comes, you are going to calculate, okay, what is the 101st coin toss is going to happen. Now before I toss I've already tossed the coin 100 times, so this is the 101st time. So what is the probability? Abdina, by making use of the data I got for the 100 coin tosses, right, I calculate the prior probability, the conditional probability, and for this toss that I'm going to do, I apply Bayes theorem and find out. Okay, so when I apply Bayes theorem will probably give me a value like the probability that now you're going to get heads is 90%. The probability that you're going to get a tails right now is 10%. Okay, so இந்த மாதிரி ஒரு ரெண்டு எல்லா கிளாஸ்க்கும், if I'm telling about a binary classifier, right, heads and tails. Suppose if you have multi-class also, for each class what is the probability, right? Because if you we all know that the sum of probabilities of each element is going to be totally equal to 1, right? So maybe if this is 50%, that is 50%. Probability of getting class A is 70, means that is 30. So here if I'm getting heads as 90, then obviously tails will be 10. So since heads has got higher probability, then I will say that, okay, the 101st coin toss will also be a heads. Okay, so I am predicting purely on the basis of statistical probabilities. Okay, so this is the Bayes theorem formula. P of H given E equal to P of E given H into P of H by P of E. Okay, so what is this term P H or H given E? It is the posterior probability of the hypothesis given that the evidence is true, right? hypothesis is whatever feature you're going to test, given that this toss is going to be true, or given that this toss is going to be false. So any probability equals P of E given H, which is these things are the ones which we calculate, right? The prior probability and conditional probability, right? So likelihood that evidence given that the hypothesis is true into probability of hypothesis and the probability that the evidence is true. So um, you will replace H and E with whatever values you are using, okay? And apply this formula, and the result that you get will tell you what is the probability. So whichever class gets the maximum probability, you are going to assign that class over here. So I'll go to example now. Okay, so here is a sample um, machine learning project utilizing naive Bayes algorithm. So here they are making use of a gender classification data set. So you can see that you're going to predict whether based on these features it is a male or female. Okay, so hair, forehead, nose, lips, all these features you're going to make some prediction. So this data has 5,000 rows and 8 columns. Okay, so when a new person's features come, your model is going to have to predict whether it is falling under male category or female category. Okay, so all these exploratory data analysis we are learning, and we are also getting a visual visualization of how the data is distributed, right? So you can see uh, the blue color value represents male, orange represents female. So there are lots and lots of different types of graphs and charts you can generate, right? So that itself can be a separate subject as such. Okay. So how many out of 5,000, what is the proportion of male and female? You can see that it's almost equal. And particular classification, right? So again, using the Bayes theorem, and the Bayes classifier itself has different types. So this is based on what type of value you're going to use, whether it is Boolean values, continuous values, discrete values, etc. Okay. So all this I'm skipping and I'm directly going to the data. Yeah. So train test split, which we've seen already, where you take your predictor columns and your target column, and you're going to split them in. So here test size is given as 0.3. So 70% for training, 30% for testing. And to make use of naive Bayes, for most of the discrete data, we will be making use of Gaussian naive Bayes. Okay, so this classifier is present again in the sklearn library. So this sklearn.naive Bayes has different types of naive Bayes implementation. So This is me calling the fit method and training my classifier, and then I'm checking the score. That is what happens when I apply the testing data. Okay, so for the training data set, the score or accuracy is 97%. For testing also, it is almost similar. Okay, so the other types of naive-Bayes algorithms are also uh, derived and used here. Okay, but you typically use only uh, one of this. Okay, you don't use all the types. Whichever is best suited for your data, you use. Okay, so 97 is the highest that we are getting for Gaussian distribution, right? So you can say that your model is able to apply the probabilistic formulas, calculate the probability that so and so value is equal to or will be indicative of male and or whether it is indicative of a female. Okay, so all this part is almost similar. So you just need to know which library to invoke and what method to call. Okay, so again, all the examples that I'm showing are very basic implementation, right? You can play a lot with the models, tweak them and make them work better and improve the performance. But we are trying to keep things simple, so I'm not talking too much about setting a lot of parameters and other things. But if you want to explore all that, you can explore that on your own. Okay, so next we will go to another type of probabilistic model, the expectation maximization algorithm. Okay, so this expectation maximization algorithm is used primarily when variables are partially observable. Okay, uh, meaning some values you are able to estimate and some values you are not able to make any sort of estimate. Okay, so that's what you mean by partially observable. And we can predict the value of these variables in instances when it's not observable. Okay, so based on the partial data you have, you are going to make predictions about the other remaining data which do not have any solutions associated. So if you take this EM problem, basically this is a simple flowchart depicting the process. So once your algorithm starts, you initialize all the values that you're going to use in your algorithm. Next is you're going to uh, make an you go to the expectation step. Okay, so what is this expectation step is? It is going to tell what all is expected at that point from all the other it could be models or variables, etc. Right? So what it is that you're expecting and what is it you are trying to maximize. Okay, so after both expectation and maximization, if you're finding that your solution has converged, that is your solution is giving a very good result, then it means that uh, your model is correctly formulated and it is working correctly. So you stop. Suppose after expectation and maximization, you still find that there are a lot of errors, where your model is not able to accurately map or implement whatever logic you are doing, then in that case, you will have to need to redo or recalculate the expectation and maximization values. Okay. And very common usage of very common usage of this sales performance of your algorithm is um, in sales performance, right? So here you can see what are the indirect variables that you're going to make use of, right? So um, things which you don't think is going to be readily used are unobserved values. So here they are called as latent variables, meaning they are not directly uh, viable or visible from a model, and you can only infer them based on the effect they have. Okay, so um, like for example, like what to say? Let's say you want to know whether uh, you have kept some food outside. Okay, let's say you have left it for some time, right? So the next day you find that you have left something outside, you forgot to keep it in the fridge. So now you know that any cooked food that if left outside becomes spoiled, right? Which is indicated by the growth of some bacteria or fungus or something of that sort, right? So sometimes by directly looking at the food, you will not be able to tell. பார்க்கறதுக்கு அதே மாதிரி தான் இருக்கும். ஃபுட் எப்படி விட்டுமோ அதே மாதிரி இருக்கும். Some food change in color, texture, or they, you know, if I keep ice cream outside, it will probably melt and become liquid. Or if I keep uh, some other liquid form, it might become solidified. Right? So a lot of things could change, but some food will be as it is. Right? So which means the changes or whatever is happening will not be observable directly. You cannot directly identify, right? But you can still infer or you can still know whether the food is spoiled or not based on some indirect way. Like probably you smell the food and then you come to know that, okay, although the food looks as though it is still, you know, um, கெட்டு போகாத மாதிரி இருக்கு பார்க்கிறதுக்கு. ஆனா the smell, when you smell it, you find that, okay, this food has spoiled. Or sometimes it could be like when you try to take it out or something, it is either then you see inside that all fungus and other things are there, right? So certain things are not directly observable or you cannot get direct measurements for those values, right? But you can observe whether it has happened or not, whether something has happened or not based on the effect it has left, right? So that is what latent variables are. Okay. And apart from that, market insights, right? So through comprehensive market analysis, you can also identify various market related insights like uh, customer preferences, competitive landscape changes, emerging segments, etc. Right? So for all this, you can make use of the for all this you can make use of the algorithm and make some predictions about things, right? So maybe so far, many people were interested in buying plastic bottles, but of late you find that people are avoiding plastic bottles. They are trying to move towards steel bottles or maybe even uh, some copper or some other metal, right? So by analyzing historical data or analyzing a lot of sales data, you can come across or you can arrive at these side of insights which are going to help you improve your business and make it better, right? So that's just a small introduction to your I'll show a demo. Okay, so a small demo for expectation maximization algorithm. Importing all the libraries. Okay, so here the previous examples, all that we saw, now these examples made use of data sets that are already available, right? So either they are available in repositories like UCI or even in Kaggle. Sometimes it's also possible for you to simulate or generate your own data set and make use of that data set in your calculation or evaluation process also. Okay, so in this example, they are generating their own data set, which is supposed to follow a normal distribution. So they are giving different constraints like what should be the maximum value, minimum value, and all those things. Okay, so here you can find the distribution. Okay, so whatever data X, right, we are generating, we are plotting it. Okay, so for the EM algorithm, you have this algorithm is going to keep repeating a particular task over and over again. So it's going to iterate for a specified number of epoch. Epoch is nothing but the number of iterations. Okay, 20 epoch, 50 epoch means 50 iteration or 20 iteration. And in each of the epoch, the E step calculates the responsibilities by evaluating the Gaussian probability density. Okay, and then you have the that is E is nothing but your expectation. M is your maximization. So maximization step, what it does is it will update whatever parameters by computing weighted mean and standard deviation. Okay, so this is the code they have given. So here epochs are defined, and for each value in the epoch, I'm finding the gamma values. So that is your E step. This full thing is your E step. That is your expectation, knowing or understanding or predicting the expectation. And once you have done that, you have some value in your hand, you then go for the maximization. Okay, இப்போ இவ்வளோ தூரம் எனக்கு வேணும் அப்படின்னு ஒரு எக்ஸ்பெக்டேஷனோட இருக்கும். அந்த வேணுன்ற வேல்யூவோட மேக்ஸிமம் என்ன? That is what your maximization algorithm does. So this is your AUC curve. Okay. So not getting too much into the implementation and the custom code that they've written. Okay, so just to show you and give you a broad or an high level idea of what expectation maximization is about. So any doubts so far on what we had covered? No doubts? Okay. So these are two commonly used probabilistic models. Okay. So naive Bayes and our expectation maximization algorithm. So we will now move to the next topic. Features. Okay. So features is nothing but your we saw about what a data set is, right? Or what a tabular form of data would look like. And what are features? Features are nothing but the various columns that we have in our data set. So working with these features is a very important task, and it is also a very difficult task because some data sets you'll find that there are very few features, rend feature, null feature. I mean, like if it's a small data set, then fine, but you can't actually make any kind of, solid you cannot give any solid solution or solid proof to something because the size of the data is lesser, right? So a lot of places features are playing a very important role. So just to understand that, we are going to learn about this topic. Okay. So what exactly is a feature? A feature is a variable, right, that has an input to the model. Okay, like for example, for uh, a student, a machine learning model which is going to predict pass percentage of students, right? So for such models, there are a lot of features you need to pass, like name of the student, the age, which class they are in, what are their marks in English, what are their marks in Tamil, what are the marks in so and so subject, right? So each such attribute is what a feature represents. As I mentioned, most of the data is going to be stored in data sets or no, or NCSV file or Excel file, and it will be in tabular nature, meaning it is going to consist of rows and columns. Okay, so these columns are called as features attributes, rows are called as instances, records, or values. All this we have learned already. Okay, and when it comes to the features, before you work with the features, you need to know what type of feature you're dealing with, right? So essentially the type of feature you're working with. Uh, Type in the sense whether your feature is a quantitative value or qualitative value. Quantitative na ஒரு numerical number ஓட associate பண்ணலாம். For example, marks for a student is 100 or marks for a student is 50, marks for a student is 30. Yes, so you can associate a numerical value for a feature, or if it is uh, result for or let's say okay, maybe things like whether this is good or whether this is okay or whether this is bad, right? So when you're trying to evaluate something qualitatively, that becomes another class of features, right? So features are in general about either quantitative things or quantitative values or about qualitative. Okay, so some examples are given here. Quantitative is probably a numerical value, qualitative is text value. Okay. So this is the different types of features that are available in Python. So you can see that based on the features, you have categorical data, array data, and numerical data. Categorical is ordinal and nominal values. Sort of like values that are used to uh, tell what sort of data your model is working with. And features can also be in the form of arrays. Okay, so when you go for array, you have embedded usage or embedded embedation of arrays, or even list concept, because list is primarily based on the implementation of uh, other concepts like arrays. And numerical data, you all know, is nothing but interracial and ratio based values. Like, for example, um, 5 to 10, that could be a value. For example, if I take the blood reports of patients, right? So if I take the feature hemoglobin, hemoglobin will be something within the range of let's say 5 to 15. Okay, so if you are having hemoglobin less than 5, it is very difficult for you to do any task. So obviously some minimum value is there, right? And there is also a maximum value. So that is what you mean by interval. And ratio is in some exercises you might come across values that are not given based on an interval, right? So in that case, you're going to basically have to guess and make use of something. Okay. So again, categorical and nominal features. Categorical, as I told, is uh, text-based features, right? So for example, um, good, bad, okay, all these are categorical. Any feature whose value is text-based. For example, if you remember the car data set I showed that day, அங்க பாத்தீங்கன்னா transmission வந்து we had automatic and manual cars, right? So automatic is one value, normal is another value. These are not numerical, but still they are used in model building, right? So all categorical data can be put under two broad categories. We call it ordinal and nominal. Ordinal is nothing but there is some order being followed, whereas in nominal there is no order being followed. For example, when I want to list choices or list something as options, right? So then I say number one is excellent, number two good, bad. So based on the words or based on what data you have, you are able to assign a feature to it. Some cases you will also find that nominal that in nominal categories there is no ordering like how it is ordered in the ordinal. Ordinal பார்த்தா excellent, excellent அடுத்து good தான் இருக்கும், good அடுத்து தான் bad வரும். Right? The order cannot be changed. Whereas in categorical, the order can be in any range. Cat, dog, cow, what sort of pets you have? Cat, dog, cow. Or I can say dog, cow, dog, cow, cat. Or I can even say right? Any combination I can call. So there is no ordering here because இப்போ excellent good bad அப்படின்னா excellent வந்து ரொம்ப ஒரு high value, badனா ஒரு கம்மி value. That is our natural understanding. Whereas cat dog அப்படின்ற ரெண்டு டேர்ம்ஸ் சொன்னேன்னா இந்த ரெண்டு டேர்ம்ஸுக்கு நம்ம ஒரு வேல்யூ கொடுக்க போறது இல்ல. So cat is not greater than dog, dog is not greater than cat. Both are like two different things. So those are categorical features. And numerical features, again, as I told, it's going to be interval based or ratio. Interval is some range, like for example, rating of a product in Amazon. Then rating falls within the range of 1 to 5. Minimum is I can give 1 star for a product. Maximum that I can give for the product is 5 stars. Okay. So here only the values that are specified by the range is applicable. A ratio value is any sort of decimal value is also allowed. Okay. So for example, rainfall in Chennai for the past 1 week. Abdin pota, each day a different value is there, and excuse me. Apart from that, the rainfall value is also not going to be like discrete values. It can even be decimal values, right? It can be whole numbers. So therefore, that comes under the ratio category. And array features. So we learned about embedding arrays. Embedding arrays is um, an array of different numerical values. Okay, and often floats. Float means floating point numbers. That is decimal numbers. So ஒரு அரேல வந்து decimal numbers ஓட வருது அப்படின்னா it is an embedding array. Okay. For example, when I want to work with image-based data, you'll find that computers cannot process images directly. So what they do, they convert the image to numerical format based on the color of the pixels and size of the image, etc. All those things, right? So இந்த மாதிரி ஒரு இது வரும்போது the image is seen as like a set of different values. Okay. So ஒரு pixelக்கும் ஒரு value இருக்கும் அந்த மாதிரி, right? So all these come under embedding arrays, whereas list array is a list of values and typically in some ordered manner. Okay, ascending order or descending order, ஏதோ ஒரு orderல array elements எல்லாம் இருக்கும். Then it is called as a list array. And so that is about basic things you need to know about features. What are the different types of features your data can have? Okay, so 3 major types, and in each major type you have 2 subtypes. Next is feature transformation. What is transformation? Transformation is nothing but changing its self, changing its form, right? So feature transformation is a mathematical transformation in which we apply mathematical formula to a particular column, transform the values, and these values are going to be used for the analysis. Okay, so feature transformation involves a lot of converting of data, modifying of data, restructuring of existing data, etc. And at the end, it is all about what sort of information you can gain from the data. For example, if I take the Diwali sales done in some shop in T Nagar, right? So how do I get that data, right? So probably I will say that, okay, so I'll take all the bills, see how many people have bought this product or that product, and accordingly, I will be able to tell what sort of sales I had. So this is one of the beautiful diagrams that you can find, right? So this features that we have, sometimes you'll find that the features are directly usable. Sometimes perhaps they're not, or they can be used directly. So in that case, you will have to apply feature engineering methods. Okay, so what is feature engineering? The first step is you construct a set of features, and then you extract the features, and then you transform the features. So how do you transform a teacher? By applying some mathematical uh, calculation over there, like feature scaling, encoding categorical data. So this again example we've seen encoding like for example good bad அப்படின்னா good enough 5, bad na 2 அப்படின்னு, right? So that is encoding. You take something and you give an alternate value. Uh, column transformers, pipeline, echo transformer, path transformers, all these the ones listed out here are different feature transformation categories. And when it comes to features, right? So once you have identified what feature you are working with, and you can transform. So transform again, for the transformation, you can apply scaling. Scaling again, in yesterday's examples, we saw how scaling of data can be done, right? So I told you that uh, I think the breast cancer data set, one particular column is measured in values of hundreds, 101, 120, 140, 150. Another column had values in tens, like 10, 20, 35, 50, etc. So this is in hundreds, this is in tens. Another column, let's say it is in some different value, right? So if you're going to have such different features in your data set, then your model might not be able to properly make use of them and give a accurate prediction. So therefore, you always try to scale your features. So scale is nothing but you are ensuring that all the features are on a common grounds. Okay, so different methods which you would commonly come across are min-max scaling and standardization, okay, or also called as Z-score scaling. So these are two of the most commonly used scaling algorithms. So what is scaling? You convert all the data irrespective of what range it is to one single range. Okay, இப்போ எனக்கு 10 features இருக்கு அப்படின்னாலும் all the 10 features are going to be having similar values, similar range values. Okay, not similar values, similar range values. And again, after scaling, you can also go for feature construction. Suppose you are not satisfied with an existing feature or column. இந்த வேல்யூக்கு பதிலா இந்த மாதிரி வேல்யூ கொடுத்திருந்தா நல்லா இருக்கும் அப்படின்னா you can go ahead and construct your own feature. Okay, again please note this is not something you can do for all the data sets. Only in certain places you will be having the option to construct a feature. Okay, so for example, how are you going to construct a feature is one thing is you um, combine two existing features into one and you get a whole new feature. Okay, so that is construction. ஏற்கனவே ரெண்டு different values இருக்கு, அதை ஒண்ணா போட்டு மூணாவது வேல்யூவை கொண்டு வரேன். Or you modify existing one. For example, house price prediction model. You might construct a new feature that represents ratio of number of bathroom to the number of bedrooms. Okay, so ரியல் எஸ்டேட் டேட்டா செட்னு வைங்களேன், அதுல வந்து ஒரு ஒரு வீடு ரோ வைஸா லிஸ்ட் ஆயிருக்கு. ஸோ அந்த ஒரு வீட்லயும் எத்தனை பெட்ரூம்ஸ், எத்தனை பாத்ரூம், ஆல் தட் இன்ஃபர்மேஷன் இஸ் தேர். Okay, sometimes maybe you feel that okay, I need not have this value separately. எத்தனை பெட்ரூம் எத்தனை பாத்ரூம் தனியா வைக்காம I will combine these two together and give it as a ratio. So what is the ratio of bathroom to bedroom? For example, if there are 2 bedrooms, 2 bathrooms, there is a 1:1 ratio. Okay, 2 bedrooms but only 1 bathroom na அதுக்கு ஏத்த மாதிரி மாறுது இல்லையா? So that by looking at the ratio, maybe people who want to buy house, some of them prefer to have same number of bathrooms as the bedrooms, so that there's no problem, or everyone gets to have their own space. In some of them who have a budget constraint in buying a house, they won't be focusing too much on the ratio of the bedroom to bathroom, right? So it depends on the customer who's going to buy the house and what they want. So rather than giving the values separately, if you give it together as a single column, by looking at one column or looking at one particular feature itself, they will be able to make a proper decision, right? So that is an example of feature construction. And that day also I told about this when I was talking about car data set earlier. I told that cars which are being sold in India, the car mileage is given in kilometer per hour, whereas a car that is sold in the US is given as miles per hour, right? So இந்த மாதிரி values mixed இருக்கு, இல்ல எனக்கு டேட்டா செட்ல வந்து மைல்ஸ் per hourல இருக்கு, but I want the answer, or I want to make use of kilometer per hour, then I will convert all the miles per hour to kilometer per hour, right? So that is again modifying existing feature. So all these come under feature construction. And you have encoding of features, right? So especially when you have categorical data, so agree, neutral, disagree இப்படின்னு இருக்குன்னா, I give as for agree the value is 3, for neutral it is 2, for disagree it is 1. Okay, and most of the models they will not be able to work with text or categorical data, so you need to give it a numerical value. So in that case, encoding is one task that you'll be doing. So again, here you can make use of one hot encoding or label encoding. Okay, so in the previous examples that I showed yesterday and day before, label encoding is what was used in most of the examples. And apart from that, you also have column transformers and pipelines. So column transformers are when you want to apply or transform your data into some other totally different type of value. Okay, so like maybe let's say my okay, let's say I have 50 data in my hand, and all the values that are less than let's say in that in a particular column, out of the 50 values, all the values which are less than, let's say, a particular value, or mean value நெடுங்களே, அந்த 50 values ஓட average value, 50 ஓட average-க்கும் கீழ இருக்க values எல்லாமே I am doing some conversion. Okay, and for all the values which are greater than the mean, I'm doing a different type of conversion, right? So again, transformer is nothing but you're changing the way your data looks like, but you can apply it not only to a single feature but also to different subsets within your particular feature. Okay, so transformers are used for transforming your data. And pipelines are used when you're going to make use of multiple transformations together, right? For example, நான் எல்லா features-ஐயும் scale பண்ணணும், scale பண்ணி முடிச்சிட்டு, or I want to, let's say, encode all the data. After encoding, I want to scale all the data, right? And then construct new data. So இந்த மாதிரி 3 steps நான் continuous-ஆ பண்ண போறேன்னா, I can make use of something called as a pipeline. A pipeline is like your regular pipe. What is the purpose of having a pipe in your house? It will allow water to flow from one point to another point, right? So same way, a pipeline in machine learning is going to allow you to send your data or pass your data from one point to another point, and in between it can go through a lot of processes. Okay, so first அது encode ஆகும், automatic encode ஆன data scale ஆகும், automatic scale ஆன data இருந்து it gets converted to a new type of value, right? So you can write codes in such a way that when you make use of pipeline, multiple operations are being done. And you will also make use of function transformers. Function transformers are nothing but applying a particular function to a feature and modifying the value. Like for example, there is a particular column called as bill amount. Okay, so what I want to do is I want to okay, maybe there is bill amount and there is a column called as discount the person has received. Okay, so each person is going to get a different value for the discount. So people who buy, let's say, above 10,000 are going to get 20% discount. People who are buying above 5,000 get 10% discount. And mari different ranges irukku. So the two data I have in two separate column. One column is what is the bill amount. The other column is what is the amount of discount they have received. Okay, so இது ரெண்டுமே நான் combine பண்ணி what I can do is I can apply the actual discount and show what is the rupees or the amount in discount they have received, rather than saying they received 5%, they received 20%, 15%. This I will give it in a numerical direct format, like this person has received 100 rupees and the 5% convert பண்ணா 100 rupees மாறுது, or the 20% that they received is actually a discount of 700 rupees, something like that, right? So when you're applying some function and performing the transformation, it comes under function transformer category. Then we have power transformers. So power transformers are specifically used when you want to change the distribution of data. Okay, and handling mixed data is another challenge you need to focus on when you're working with features, right? So when your data contains both numerical and categorical, you need to ensure that all data is in a similar format. And handling date time data. Okay, another main type. Unlike direct numbers or direct text, date time works slightly different, right? So date time la irundhu addition subtraction lam pandrom 3 days before today, 10 days after today abdina, the calculation with dates and times is slightly different, right? So if you want to ensure that you are working specifically with date and even after the addition subtraction the format does not change, you can make use of a lot of techniques which are available. And handling missing values. So again, when you talk about features, some features will have some missing values. Missing values, someone would have forgotten to enter a value, or by mistake it got deleted, and therefore there is no value for a particular row of data. That is, you have all the values, but one or two features, the values are missing or absent, right? So in that case, how do you rectify the missing value? You can calculate the mean and use it, or you can even calculate the mode and use it. Okay, so different options are there, so you can use any of that to handle the missing values. And finally, handling outliers, right? So as I already mentioned, the presence of outliers will disturb the performance of a model. Why? Because these are extreme values. அது வந்து ஒரு நல்ல இதுன்னு அக்செப்ட் பண்ண முடியாது, because majority of your data is in one thing and these outliers are somewhere else, right? So if I'm going to give too much importance for the outliers, then the performance of my model will go down, right? So in some data sets you have very few outliers, means you can very well remove those outliers and use the remaining data, right? In some places outliers are again cleaned, meaning uh, okay, in the particular class 6, grade 6 students la, this one person alone is very tall. அப்படின்னா அந்த ஒரு பர்சனோட டேட்டா மட்டும் அவுட்லியரா தனியா வரும். So one thing is I can have it as it is and implement my model. Another thing is I can remove that person's record and implement that model, or I can try to balance out his height, ensure it comes at least near the range of the other student's height, and then make use of that value in the whatever calculation I'm doing, right? So all these are um, different operations you do in feature engineering. Yes. So ஒரு ஃபீச்சர்னு எடுத்தா நம்ம கொடுத்துருக்க டேட்டா செட்டை அப்படியே யூஸ் பண்ண முடியாது. Definitely at least one or two of whatever techniques we have studied you will be applying in your data. Okay, so only after engineering or making some change to the features, it becomes easy for your model to learn from the data. Okay, so next is how features can be selected. So maybe we'll go for a short 10 minutes break and come back because this is again a big topic. So maybe we'll take a 10-minute break and come back. You all can make use of a break. We'll start at 3:30. Yes, I think all of you would be back from your break by now. So continuing from where we left off. So the next that we are going to learn with regards to feature is about the process called as feature selection. So what is feature selection is in a data set, when you have multiple features or many features listed out, you'll find that not all of them are going to be um, probably having a positive impact on the result. Okay, so the job here is to identify features that are not really having any effect in the outcome of the prediction or classification result that your model is going to come up with, right? So if the feature is not going to have any impact on the result, then you need not have that feature in the data set at all, right? So better to remove it, because when even if you remove one feature from a data set, the size of your data set is going to reduce, and not only that, the processing time as well as storage, everything goes down, right? So feature selection is a technique that you'll find being utilized in many machine learning problems, right? To ensure that only optimal features, meaning features which are having high influence or high impact on the end result, are being utilized, and the ones that do not have much importance or they do not have a big influence are removed from the data set. Okay, so if you remember that day I told you about an example of having the feature called as a color of a car in the car data set, right? So color of the car and the price are not really going to be having a big correlation, or price is not going to have a big impact on the color is not going to have a big impact on the price, right? So like that, you try to identify what all features you can remove from a data set and you remove them. Yes, but one thing to note here is it's a very carefully done process, because by mistake, if you remove a feature which is having a very high influence on the outcome, then by removing such important columns, your model will fail in its performance, right? So கண்டிப்பா accurate result கொடுக்காது. Moreover, அதோட prediction எல்லாமே தப்பா இருக்கும். And certain cases, um, there's no point in using a model if a particular feature is not taken into consideration. For example, in the case of car price prediction, the brand of a car is very important, right? So without brand, I cannot just randomly predict a price, right? I cannot say that uh, one I-10 and one Creta are of the same range. Okay, ரெண்டுமே நான் 7 lakhs or 3 lakhs அப்படின்னு கொடுக்க முடியாது, right? Because it's going to, I mean, the model, the make is going to make an impact. Or apart from the model, even the brand could be like maybe Hyundai cars are slightly priced lower than let's say Volkswagen or a Skoda, right? So I cannot ignore the brand name and price Hyundai cars in the same way as um, your Skoda or Volkswagen, right? So important features when removed from your data set have a uh, negative impact, or they might have they might be make your model totally inaccurate or unreliable for any prediction. Okay, so to perform this feature selection, three types of methods are available. So any of these can be used. Okay, so first one is filter methods. Then we have wrapper methods and embedded methods. Okay, so we are going to learn about each of this in detail. Okay, so filter methods. Okay, so before going to filter method, a quick look at the role of feature selection to reduce the dimensionality of the feature space, to speed up your learning algorithm, to improve the predictive accuracy of your classification algorithm, and to improve the comprehensibility of the learning result, right? So all this is what I mentioned just few minutes back. It's given out here as text. And coming to filter method. So what is a filter method? How are you going to implement this and remove or select only the essential features? Okay, so filter methods are a class of different methods which are typically statistics based methods, right? So these are done during the pre-processing of your data. Okay, so if you're if you know that you're going to have to apply feature selection and select, let's say out of 10, I want to select only 7 features, whichever is the best 7. The other 3 I'm going to ignore. Abdina, in the 7 one, I'm going to select it during the pre-processing of my data. Pre-processing is like when you perform the cleaning and other data transformation task itself. Before I build a model, at that point itself, I'm going to remove all the unnecessary features or select only the ones which are important. And advantage of filter method is that it is going to be executed very fast, and it is also inexpensive. Inexpensive in the sense that it'll consume very little resources like time or space. Yes, so filter methods are widely used for most of the small scale problems. Okay, because that is sufficient to identify and choose and filter out whatever is not needed. Okay, so how does your filter method work is, first it takes all the features and then select the best subset from the feature, apply the algorithm, check the performance. Okay, so let's say there are 10 features. It takes all the 10 features together, and from the 10, it is going to assign a score or something for each feature. Okay, and from that I will be able to choose whichever column or whichever feature is having higher impact and choose only that. So I told that out of 10 I want 7. So for each of the 10 columns I'm going to give a rank from 1 to 10. So except rank 10, 9 and 8, the other features I will take, form it as a subset, apply the algorithm, get the performance. Okay. So as I told, this is a very fast method because it is a very simple process that's being followed. The main uh, thing here is how are you going to give the rank for the features which you're going to select. இப்போ நான் 1 to 10 rank கொடுத்தாதான் எனக்கு first 7 rank எடுக்க முடியும் இல்லையா? ஸோ அந்த ரேங்கிங்க்கு என்ன டெக்னிக் யூஸ் பண்ண போறேன் அப்படின்னா, as I told earlier, some statistical based techniques like information gain, chi-square, Fisher's score, correlation coefficient, all these are various statistical tools which you can, methods which you can use to assign the or analyze the importance of a feature. Okay, so important features will have higher values and the ones which are not important end up having lower values. So from that easily I can filter out and then the second class of methods are wrapper methods. Wrapper methods are greedy and iterative in nature. Greedy in the sense, most of the wrapper based methods are greedy algorithms. What is a greedy algorithm? A greedy algorithm is an algorithm which is always striving to choose the best. Okay. Um, See, for example, when do you call a person as a greedy person? When you give something to them, they are not satisfied. They still want more and more and more, right? So, in a similar way, your algorithm wants to find the best out of something, right? It wants to find the best features. A greedy algorithm is ஒரு தடவை கண்டுபிடிச்சா இது பெஸ்டா இருக்குமா இல்லையா இல்ல இதை விட பெஸ்ட் இருக்குமா, நான் மறுபடியும் சர்ச் பண்றேன்னு அகைன் இட் பெர்ஃபார்ம்ஸ் அ சர்ச், ரைட்? அதுல ஒரு ரிசல்ட் வரும். ஓகே, தீஸ் ஆர் த நியூ பெஸ்ட் வேல்யூஸ். இல்ல இதை விட இன்னும் கொஞ்சம் பெஸ்டா வேற ஏதாவது இருக்கும் அப்படின்னு சொல்லி இட் கீப்ஸ் ஆன் சர்ச்சிங் till it tries out all possible permutations and combinations, right? So if there are 10 features, what if I have column 1, 5, 6, 9 அந்த மாதிரி ரேண்டமா சூஸ் பண்ணி இதுக்கான ரிசல்ட் என்ன, இப்போ இதே காலம்ஸை மாத்தினா அதுக்கான ரிசல்ட் என்ன? ஸோ லைக் திஸ் இட் வில் கீப் ட்ரைங் அவுட் ஆல் காம்பினேஷன்ஸ், கெட் தி ரிசல்ட், அண்ட் அந்த ரிசல்ட்ல எது பெஸ்டா வருதோ அதை சூஸ் பண்ணும், ரைட்? ஸோ greedy and iterative in nature, and a stopping criteria must be defined. So as I told, since this is going to be a highly repetitive task, a stopping criteria should be defined. Otherwise, the algorithm will keep on, checking and checking and checking without stopping. Check பண்ணிட்டே தான் இருக்கும். So you have to definitely give a stopping criteria. And generally, all wrapper methods have better performance than filter methods, but they are not going to be as fast as filter. So definitely slow because you are applying the same function again and again and again and checking the result, rechecking everything. So kandipa time jaasti எடுக்கும், and it is also uh, uh, computationally expensive, meaning it will take up a lot of resources. Okay, so if your data is very complex, it is better to go for a wrapper method to apply feature selection. But if you have simple data, applying a wrapper method is a waste of time. Yes, direct or filter method apply பண்ணி filter பண்ணிட்டு தேவையான features மட்டும் எடுத்துட்டு போகும். But for complex data, filter methods will not work out because they will not give accurate result. So in such cases, wrapper methods are good. Okay. So how does a wrapper method work? So from the set of all features, you consider a random subset and then you apply the algorithm. You check whether there is some other best subset better than this. அப்படி ஏதாவது கிடைச்சதுன்னா அதை எடுத்து டெஸ்ட் பண்ணுவோம். So like that, you keep repeating this till you try out all combinations, or if that number is too big, you till a stopping criteria is met, you keep repeating this process. Once the stopping criteria is met, whatever you have chosen as the best result, that will be used for evaluation. Okay, so some of the commonly used techniques and wrapper methods are forward selection, backward elimination, bidirectional elimination, and recursive elimination. Okay, so wrapper methods are greedy, they are slow, they are expensive, but they are going to give better result when your model becomes complex. And the third type is embedded methods. Okay, so embedded method is a combination of you know a little bit of feature and little bit of wrapper. Okay, so best of both worlds அப்படின்ற மாதிரி. So it is a method of blend when learning, and it is also fast as well as better, right? So but still not as fast as filter methods and not as slow as wrapper method, somewhere in between. And unlike the other two, this is it's not going to give filter methods. Typically if they don't work correctly, you'll get very mediocre result. Wrapper methodல கண்டிப்பா நல்ல result வரும், ஆனா டைம் ஜாஸ்தி ஆகும். இதே embedded method போனா டைம் கம்மியாகும், plus you'll also get a better result. So it's a best taken from both filter and wrapper and put together, right? So you can if you look at the process, it's almost similar to what is being done in a wrapper method. So from this list of all features, you select certain sub feature and you apply the algorithm and check the performance, right? So previous is you only apply the algorithm and you keep applying it for all the subset. Finally you compare the performance, take what is best. இங்க வந்து ஃபைனலா வெயிட் பண்ணி கம்பேர் பண்ண போறதுல அப்பப்ப உடனே உடனே யூ கோயிங் டு ஓகே இந்த காலம் 1 5 10 எடுத்திருக்கேன் அப்படின்னா இதை வச்சு நான் மாடல்ல ரன் பண்ணா எனக்கு என்ன ரிசல்ட் வருது. I take it, compare it to the previous result that I have. Okay, if it is better, then this subset that I've chosen is better. If the current the previous value which I took itself is better. So adukku edha mari I further go keep searching for new subsets. I repeat both implementation and performance evaluation together, and then use that knowledge to make a decision on selecting which is the best subset of features. Okay, so some of the commonly used embedded methods are regularization and tree-based methods. Okay, right. So any doubts so far in whatever has been covered so far? With regards to features, feature engineering process, the feature selection, methods, techniques, no doubts? Okay, so we'll move to the next topic then. So the next topic is about ensemble methods. Okay, ensemble means a combination. Okay, so multiple things put together. So a typical ensemble model is when you integrate 2 or 3 models together. Okay, இப்ப நான் ஒரு linear model இல்ல ஒரு tree based model அப்படின்னு யூஸ் பண்ணா அதுல வர accuracy வந்து ஒரு வேல்யூவா இருக்குன்னா, when I combine multiple models and run them together, um, definitely my accuracy will become little bit higher than running the models individually. Okay, so that is the general idea behind the concept of ensemble models, okay, or ensemble learning. So here we have 2 techniques being used in ensemble. The first technique that we're going to learn is called as bagging. Okay, bagging is nothing but it is short form for bootstrap aggregation. Okay, So bootstrap aggregation is nothing but you are going to like apply multiple models, okay? And what you're going to do is you take the result of each model and use it together, use all the results collectively together and make a prediction, okay? And it is done under the assumption that when rather than taking one thing, taking multiple things is better. See, for example, when you're going to buy, let's say, a new car or a new bike, so or even a phone, right? So you go and ask your friends for some information regarding maybe you want to you're having some confusion in buying this particular car X or car Y. So you go ask your friends, right? So person one tells buy this particular brand. Person two tells no, you buy the other brand, right? So like that, each of them will give an opinion. So obviously you will always go for the one where most people prefer. Okay, இல்ல இந்த பிராண்ட் வந்து 4-5 பேர் நல்லா இருக்குன்னு சொல்றாங்க, இந்த பிராண்ட் வந்து ஒருத்தர் நல்லா இருக்குன்றாங்க, இன்னொருத்தர் நல்லா இல்லைன்னு சொல்றாங்க அப்படின்னா, you collectively get the information from multiple people and combine that together. அதுல majority எந்த இதை நல்லா இருக்குன்னு சொல்றாங்க, that is what you'll also proceed with, right? Whatever it is, a phone or a car or even a mixer or grinder that you're buying for your house, that's how you typically go and select a brand or a model and buy it. So the same concept is what bagging or bootstrap aggregation uses, right? So it is an ensemble method that combines the prediction from multiple machine learning algorithms together to make more accurate prediction than any individual model. ஒருத்தர் கிட்ட நான் போய் கேட்டுட்டு ஓகே அவங்க வந்து இந்த XYZ பிராண்ட் நல்லா இருக்கு அப்படின்னு சொன்னா நான் டைரக்டா அவங்க சொன்னதை நம்பி வாங்க மாட்டேன். So of course I will always check with more than one person, because if 2 or 3 people are going to tell that this is better, then I have more confidence in saying that okay, this brand is actually better only, right? So that's the idea here. Okay. So one of the most widely used bagging algorithm is called as a random forest algorithm. Okay, so what is random forest? So as the name suggests, it is a totally randomly chosen technique. And the term forest is nothing but in general, what is a forest, or what do you say is a forest? A forest is a place where there are many trees or many animals, right? So essentially a place where you have more trees, you call it as a forest. So remember we learned about the tree models, and I told you we discussed about basic tree called as a decision tree, right? So a combination of multiple decision trees together is what a random forest is. Okay, so ஒரே ஒரு decision tree யூஸ் பண்ணாம ஒரு 10-15 decision tree use பண்ணி I get the result of each of the 10 or 15 trees that I have chosen, and from the 10 results that I have, I choose which is best. Okay, so that is how the random forest algorithm works. Okay, so build multiple decision trees, each with a randomly chosen subset of features. Okay, so of course, if you're going to build multiple trees, the trees have to be different, right? ஒரே ட்ரீயை 10 தடவை பில்ட் பண்ணிட்டா ஒரே ரிசல்ட் தான் வரும் 10 தடவையும். So there's no point in using that. So if I'm going to build multiple things of something, then I need to ensure to build each differently. Only then I will be knowing which one is better suited, right? So maybe based on different techniques or based on different um, subsets, I will randomly choose different values of subsets and randomly generate a decision tree, check its result. So like this 10 or 15 or even 100 trees I can build and compare. Okay, so final result is if depending on your problem, if you're using it for if you're using random forest for a classification problem, binary classification or multi-class classification, it applies a voting strategy. Voting is nothing but 10 ட்ரீ இல்ல 15 ட்ரீ பில்ட் பண்ணியிருக்கோம் அப்படின்னா இந்த 15 ட்ரீஸ்லயும் என்ன ரிசல்ட் வந்துச்சு. ஐ அப்ளை அ vote. Whose or which answer is getting most highest vote? Maybe let's say I have a picture and each tree is going to predict whether the picture is a bird or a cat. Okay, so out of 15 trees, 10 trees are telling that it's a bird, 5 trees are telling that it's a cat. So by applying the voting, I go for the highest voted. So which is 10 trees are telling that it's a bird. So which means my answer is also going to be this particular image is a bird. Okay, so this is for classification, whereas for regression task you apply averaging. Okay, regression, for example, இந்த காரோட price predict பண்றேன், நான் random forest use பண்ணி different features வச்சு predict பண்றேன். Maybe in the first tree I give more importance to the mileage of a car, அதுதான் main check பண்ணுவேன். In another tree I am giving the brand of the car as the most highest priority. ஓகே, அதுக்கு ஏத்த மாதிரி தான் மற்ற இதெல்லாமே செக் பண்றேன் pricing-க்கு. In another tree I go for a different feature. So like this, let's say I have 5 trees. Now to get my final result, since it is a regression task, meaning it will give you a numerical value, I take the average of the 5 trees and display it to the user. Okay, so one major advantage of going for ensemble models or collection of multiple models is that overfitting can be greatly reduced in such models. Okay, why overfitting is reduced is because you are using the same data and training it multiple times. இப்போ ஒரு 100 trees build பண்றோம்னா கண்டிப்பா அந்த 100ல ஒரு 4-5 ட்ரீ வந்து ஓவர் ஃபிட் ஆன ட்ரீயா தான் இருக்கும். மீனிங் இட் would have learned too much and it is started to generalize the prediction outcome without thinking. It is directly giving answer, but out of 100 that is only like 5 or 10 trees. The remaining 90 are learning properly and giving you a proper result. So obviously, though you take a majority voting or you apply averaging in the case of regression, you are still getting the best. You're considering the remaining best and only getting majority influence from those best trees. So which means overfitting will have very little impact when you go for implementing multiple models and taking the best result out of those. Okay, so that is what random forest does. Right, so this is a sample picture of how a random forest algorithm would work. So you have the full data set here. So you can see different trees are being built. Okay, each tree is a single decision tree. So collectively multiple trees form your random forest. Okay, so in the tree la outcome pathina class A. In the tree tree number 2 is giving the outcome as class A. Tree number 3 will give another class, etc. Tree number n is giving the outcome as class B. Right, so I take the answers of all these and apply the bagging or the voting and find the majority. So majority says it is class A. Therefore, my prediction output is also going to be class A. Okay, so this is how the random forest algorithm works. And the second technique in ensemble modeling is boosting technique. Okay, so boosting is an ensemble technique which attempts to build a strong classifier from individual or number of weak classifiers. Okay, so அங்க வந்து நான் மொத்தமா ரன் பண்ணி ஃபைனலா நான் ரிசல்ட் எடுத்து அதுல இருந்து மெஜாரிட்டியோ இல்ல ஆவரேஜோ எடுத்து போடுறேன். பூஸ்டிங்னா I build individual classifiers, I make them run and I try to correct them as they are and build the next one. Okay, so we'll look at the process. So it is done by building a model by using weak models in series. Okay, so first a model is built from the training data, and that first model will give you a result. Let's say it is giving 75% accuracy. 75% தான் வருதுன்னா அதுல என்ன எரர், என்ன அந்த மாடல் மிஸ் பண்ணிருச்சு அப்படின்னு கண்டுபிடிச்சு யூ ட்ரை டு கரெக்ட் இட். ஓகே, ஸோ ஒன்ஸ் யூ கரெக்ட் யூ அகெயின் use a model for making another prediction. Okay, first நமக்கு 75% வந்துச்சு, so I have done some corrections in the way the model works. Now when I predict, Let's say it is giving me the result as 80%. So which means my performance has increased. Yes, so from 75 it has come to 80. So 80 ல இருந்து further improve பண்ண முடியுமா அப்படின்னு பார்த்துட்டு I keep tweaking the model again and again and again till I end up at a point where the prediction accuracy does not go up beyond that point. Maybe I will come up to 93%. Okay, 93க்கு மேல எதுவுமே எத்தனை தடவை எதை கரெக்ட் பண்ணாலும் போகல அப்படின்னா 93 is your final outcome, right? So what are we doing here? Essentially, you take a weak model. The first model which gave you only 75% accuracy is a weak model, right? It was not able to give a proper prediction accuracy, but you still use that and you did some corrections, and that model has now performed a little better and gave 80%. Then further you did some correction, and further upon making correction upon corrections, you finally brought it to 93%, which means your model, weak model, has become a strong model. So 93 க்கு மேல increase பண்ண முடியலன்னா that is your strongest model. Yes, maybe அதுக்கு மேல எந்த சேஞ்சஸ் பண்ணாலும் accuracy குறைய ஆரம்பிக்குது, 93ல இருந்து திருப்பி ரிவர்ஸ்ல வருதுன்னா of course you will stop it at that point. Okay, so this is continued till all models are added, until the complete training data set is predicted correctly or the maximum number of models are added. Okay, so here is a sample picture of how a boosting algorithm works. So this is my data set. Okay, first I apply one particular classifier which tries to predict or cluster the data or group your data. Okay, so இதுல ஒரு result வருது. So இப்போ இந்த result வந்து அவ்வளவு satisfying இல்லை அப்படின்னா I take this result, do some adjustments or corrections, again apply the classifier, again make a prediction. Then again I take this result, do some changes, apply the classifier, do some prediction. I keep repeating this process till I get a high performance output. Okay, so some of the common boosting algorithms that you will come across are AdaBoost, gradient boost, XGBoost, and CatBoost, right? So all these boosting algorithms work as I mentioned, and rather than going for individual models, always bagging as well as boosting algorithms give better result. Of course, bagging kum boosting kume பாத்தீங்கன்னா சில டேட்டா செட்ல பேக்கிங் பெர்ஃபார்ம்ஸ் பெட்டர், or in some data sets boosting algorithms perform better. That you will only be able to find after implementing and seeing which is giving better performance, right? But in general, compared to individual modules, these ensemble models always give you a higher result. Here is a small classification or a distinction between boosting and bagging. So boosting is combining predictions that belong to different types. Bagging means combining the same type of prediction. Okay, meaning random forestல பாத்தீங்கன்னா எல்லாம் கிளாஸ் தான் predict பண்றாங்க இல்லையா? It says class A or class B or class C, and from that you take the result, take the majority and combine. Here you are combining the prediction that could be of any type. See, first time I could get a value, second time I could get some other value, third time I could get another value. 75% ல இருந்து எப்படி increase பண்ணி 93 க்கு வந்தோம், right? So here the main aim of boosting is to decrease the bias rather than the variance, whereas in a bagging algorithm the variance is tried to reduce rather than the bias. And at every successive layer, models are weighted according to the performance. Here all the models have the same weightage. Okay, இப்போ random forestல நான் என்ன சொன்னேன், 10 ட்ரீ இருக்குன்னா 10 ட்ரீயோட அவுட்புட்டையுமே நம்ம கன்சிடர் பண்ணுவோம், அதுல இருந்து மெஜாரிட்டி அப்ளை பண்ணி எடுக்கிறோம் இல்லையா? which means I'm giving equal opportunity to all the trees. Whereas in boosting, if the first model is not having good performance, only you go for the second model. ஓகே, அதுல ஏதோ இம்ப்ரூவ் பண்ண முடியுது அப்படின்னா, இல்ல இப்ப நான் ஃபர்தரா சேஞ்சஸ் பண்ண டிக்ரீஸ் தான் ஆகுது, இன்க்ரீஸே ஆகலைன்னா, the later models are not going to be considered at all. The previous, whichever gave me the highest result at some point, that is the value that I'm going to consider. Okay, so 75 ல இருந்து 80, 80 ல இருந்து 85, 85 to 90, 93 வருது. 93க்கு அப்புறம் திருப்பி 85, 80 அப்படின்னு போகுதுன்னா, though I have come across different models, the point where I got the highest one, 93, that is what I will be taking. Okay, so that's what they're trying to tell here. And new models are influenced by the accuracy of previous models, whereas in a bagging technique, all the models are independent of each other. Okay, so that is 10 decision trees இருக்கு அப்படின்னா, some are telling it is class A, some are telling it is class B, right? இது cat, இது bird அப்படின்னு சொல்லுதுன்னா, ஒரு மாடல் கேட்னு சொல்றதுக்கும் இன்னொரு மாடல் அது கேட்டோ பேர்டுன்னு சொல்றதுக்கு சம்மந்தமே கிடையாது. They are working independently. But in the case of a boosting algorithm, right, as you can see here in the image clearly, the previous model has some influence in the next model, right? ஏன்னா இதோட அவுட்கம் எடுத்துதான் நம்ம ட்வீக் பண்ணி ஒர்க் பண்றோம். So obviously that model will have an impact here. Whereas in the case of a boosting bagging algorithm, this is separate. This is separate. Like that, each tree is separate. It is not having any influence on each other, right? So there's no influence and they are independent in bagging, whereas in boosting they are having some influence from the previous model. Okay, so these are some of the bagging and boosting algorithms. So any doubts in whatever has been um, discussed so far? Okay, so I think we can go for a demo session. Okay, right. So coming to a small example regarding how to use random forest classifier. Here, I'm skipping all this theory part. So first things first, I get the data set, the same car price prediction, the car evaluation data set, doing some exploratory analysis and some pre-processing. And finding the predictor column and the target column. Once I'm done with that, I apply train test split, and I'm splitting my data set into training set and the testing set based on the ratio. Training set is almost 60%. I mean, like 66 point some percent, and your test set is around 33%. And of course, to check which features I want to use and which features are needed or not, I apply some feature engineering task like either converting something or removing, scaling, encoding. All these I can apply, right? So first thing is I've encoded. That is, you can see these values like very high, high, low. So instead of text, I will change it to numbers. Okay. So you can see what we had as text. ஹை லோ அது எல்லாத்துக்கும் ஒரு வேல்யூ. ஹைனா 3, லோனா 2, அந்த மாதிரி. Likewise, small, medium, large, that will get its own value. Okay, so that is encoding. And here we are applying the random forest classifier. Again, this is present in the sklearn library. So model RFC equals a random forest classifier. And again, I've already told you what this random state does, so I'm not going to repeat it again. Directly we move on to training my data set on this particular model and later using that model to predict my test set. So if you look at the accuracy, I'm getting 92% accuracy for model accuracy score with 10 trees. Okay, so by default, this particular random forest is building a forest which contains 10 trees. Okay, so in the 10 trees order, average என்னவோ or the best value என்னவோ அதை எடுத்து you find the accuracy. Okay, so here what they've done is instead of 10 trees, they've changed n estimators. N estimators is nothing but it is a parameter that helps you control how many trees your forest needs to have, right? And if your data is large, you need to have lots of trees. Okay, if your data is somewhat medium sized but very complex, again large trees are helpful. என்கிட்ட இருக்க டேட்டாவே ரொம்ப சின்னது அப்படின்னா நான் லார்ஜ் நம்பர் ஆஃப் ட்ரீஸ் பில்ட் பண்ணி யூஸ் கிடையாது. பிகாஸ் பியாண்ட் அ பாயிண்ட் it will start repeating or create the same tree again and again, right? So in that case, there's not big influence of your trees. So here you can see random forest classifier with n estimators as 100. Then again, I'm using it to train my model and test it, and I'm printing the accuracy. It says it is 94%. Okay, so with a forest with 10 trees gave me the accuracy as 92%, but the same thing with 100 trees, nothing else I've changed. Okay, just the number of trees in the forest have changed. So more trees means better accuracy. Okay, so again here, uh, what to say, not always it'll be a positive impact. Okay, sometimes when you like increase the number of trees beyond a threshold, the performance starts degrading or it will remain the same. சேமா இருந்தா கூட பிரச்சனை இல்லை, ஆனா குறைய ஆரம்பிச்சிருச்சுன்னா அதுல யூஸ் கிடையாது, ரைட்? Okay, so the tree that you have built, you can check how or what features were used in the tree to build, I mean, like to predict your answers, right? So that is what they've done here. Feature scores is to find out, okay, இந்த காலம்ஸ் எல்லாம் இருக்கு, இந்த காலம்ஸ்ல எந்தெந்த காலம்ஸ் என்னோட random forest algorithmல யூஸ் ஆச்சு, அதெல்லாம் யூஸ் ஆகல, right? So what you see over here is a score associated for each feature. For safety, the score is 0.29 for person. Okay, so based on the score, you will try to choose columns and build a tree. Okay, so they have shown it in the graph form. So which to predict the price of a car, safety of the car is having very high importance. Yes, so in this particular example, safety is the most highly contributing example, I mean feature. Persons, like how many persons can sit in the car, that is again another thing. Because if I'm looking for a big family, I need to go for a bigger car. So of course, this number of seats is important. Then other features, and the number of doors in the car is not that important. So it is one of the least ranking features. So out of these 6 features, I have to choose any 4, means I will choose the first 4 because they have more importance in the feature scale. And all this you can explore and learn. Okay, so that's about how a random forest algorithm can be used. So next I will show one boosting algorithm. Okay. So for boosting, I'm taking the XG boost algorithm. Okay. So here uh, they are making use of a data set called as adult, which is your um, adult income data set. Okay. So here the prediction is to specify the salary a person makes. Okay. So like based on the age, what working class they belong to, education, experience, etc., etc. You're predicting what sort of income they will have, greater than 50,000 or less than 50,000. Okay, so this is what your data set is about. And all this exploratory data analysis you're doing, data pre-processing again. And as usual, predictor columns, target columns are split as X and Y. And then you go ahead and apply the prime test split. And here I'm making use of the XGBoost classifier. So XGB classifier. Okay, so from XGBoost library, import XGB classifier. So again here, if you see, there are a lot of parameters being set here. All this is something which you can change, give different values, try and check uh, what sort of result you're getting. Okay, so n estimator is equal to 500 Abdina. 500 different results are going to be, or different combinations of features are going to be taken and compared. Okay, so அந்த 500ல எது பெஸ்டா தருதோ அதுதான் அவுட்புட்டா வரும். And you're also fixing something called as a learning rate. This learning rate is a error parameter. Okay, um, why we have such an error parameter is, suppose my model is making a wrong prediction, or it's not very accurate. Okay, then I will say that, okay, I have to give some I'm going to change the learning rate. Okay, so learning rate mara the model or performance மாறும். Okay, so what sort of encoder you want to use? I don't want to use any encoder because all my data is in numeric format. டெக்ஸ்ட்ல ஏதாவது இருக்கு அப்படின்னா இதை ட்ரூன்னு கொடுக்கலாம். Evaluation metric on what sort of function I'm going to evaluate it on, and stopping criteria around this 5. Okay, so you build a model like this by specifying the parameters. You can adjust and learn which is better. Okay, so for each data set, a different set of parameters will work or give you better results. Okay, and finally, we are calculating accuracy. Accuracy is found to be 87%. Okay, so here they are doing a small comparison between logistic regression and XGBoost. So so the logistic regression model gave a score of 0.77, whereas XGBoost gave a score of 0.88. So you can see there is at least 11% increase in the performance of your model when you change from a single model to an ensemble model. Okay, that is a collection of models. So any doubts so far? Yes, someone has raised your hand. Do you have any doubts? You can put your message in the chat. Okay. So with this, we are completing our portions. Okay, so if you have any doubts in any of the concepts we've seen from the first class till now, you can ask and get your doubts clarified. Or if you want any other further clarification or வேற எதா பத்தி கேட்கணும்னாலும் கேட்கலாம். Yes, does anyone have any doubt? Yeah, I'll be sharing the notes with Permal sir. He will be sharing it in your respective groups. Okay. And again, one thing I need to tell is with regard to your exam perspective, these notes are whatever PPT I've used has very little theoretical content. Exam க்கு கண்டிப்பா இது எழுதுனா பத்தாது. So this is just for you to gain an understanding on the concept. Okay. But of course, the theory part, இப்போ நான் சொல்ற அளவுக்கு content PPT ல இருந்திருக்காது. So all that extra content you have to refer to the book, or you can even refer to lots of online web resources. If possible, I will also send links for related resources which you can learn. Okay, so and of course உங்க examல எழுதும் போது they will expect you to write theory, right? So for that purpose you can make use of any book or any website or blog which has discussed about whatever topics we have learned so far, right? And as I mentioned, I've chosen very simple examples and only given. நீங்களுமே இப்ப வேற ஏதாவது எக்ஸாம்பிள் தேடி படிக்கிறீங்க அப்படின்னா ensure it is not a very complex example. Okay, take a simple example, um, learn how it is being implemented, etc. Any further doubts? Okay, a very silent batch. Most of the previous batches people usually ask a lot of questions even during class. You're all very silent.